Good morning, ma'am.
Yes, good morning, students. So today we are going to discuss the topic solutions. Okay, so what are solutions? Yes, what are solutions? Solutions are homogeneous mixture which consists of two or more components, right? Homogeneous means what? It consists of same properties. The composition and the properties are same. That is, it is uniform throughout the mixture. Okay, so solution. So we are going to start with the topic solution. So we'll see how to determine the strength of the solution. So the amount of solute. Okay, so there is something called as solute, solvent. So these are terms which are used in solution. Okay, solute. So the amount of solute which is dissolved per unit solution or solvent is called as strength of solutions. Okay, so how do we express the concentration of solution? Okay, so there are different methods for expressing the concentration of solutions. So the first is mass percentage. So when you find the, if you want to express the concentration of solution in terms of mass percentage, how it is given. So these are different formulas, okay, for expressing the concentration of solution. So first is mass percentage. So it is the mass of solute divided by total mass of solution into 100. Okay, so this is how you calculate the mass percentage. So mass of the solute divided by the total mass of the solution. Next is mass by volume percentage. So how do you calculate mass by volume percentage? Okay. So that is mass of the solute in grams. Okay, mass of the solute in grams divided by total volume of solution in ml. Okay, into 100. So this is how you calculate your mass by volume percentage. So it is mass of the solute in grams divided by total volume of solution in ml. Next is volume percentage. So how do you calculate a volume percentage? It is volume of solute divided by total volume of solution into 100. Okay, so this is volume of solute, total volume of solution into 100. Then parts per million. Parts per million means what? Parts per million. How do you calculate? So it is number of parts of solute divided by total number of parts of all components of solution into 10 raised to 6. Okay, so this is the way you express your parts per million. Next is mole fraction. Mole fraction. Okay, mole fraction. So how do you calculate mole fraction? So psi of A is equals to Na divided by Na plus Nb. Then psi of B is equals to Nb divided by Na plus Nb. So when you want to measure number of moles, okay, of that particular component to the total mixture of that, okay. So this is mole fraction. So psi A plus psi B is equals to 1. Then molarity. Molarity is what? It is a number of moles of solute which is dissolved in 1 liter of solution. So this is number of moles of solute divided by volume of solution in liters. Okay. So the unit is mole per liter. Molality is nothing but number of moles of solute divided by it is dissolved in 1 kg of solvent. That is mass of solvent in kg, 1 kg. So it is mole per kg. Okay, so this is the unit of molality. Normality, how do you calculate normality? It is a number of gram equivalent of solute divided by volume of solution in liters. Okay, so it is what? Number of gram equivalent of solute divided by volume of solution in liters. The unit of normality, it is given as N. Okay, N. Then formality, it is a gram formula mass of solute divided by volume of solution in liter. So it is expressed in terms of mole per liter. Okay. So what is the relation between these concentration different terms? So first we'll see the relation between the molarity and normality. Normality, that is molar mass divided by equivalent mass into molarity. So normality, molar mass divided by equivalent mass, it is given as N. Okay, after this you get N small n into molarity. So molarity of diluted solution. So if you want to calculate the molarity of diluted solution, then how do you calculate dilute? It is M1 V1 is equals to M2 V2. Okay, M1 V1 is equals to M2 V2. Then molarity of mixing means what? If you have a mixed solutions, okay, different solutions, then M1 V1 plus M2 V2 plus M3 V3. So you take a resultant of this M, so that is MR into V1 plus V2 plus V3. So this is the molarity of mixing, where MR is the resultant molarity. So you take the resultant of all the this and you add the volumes. Okay. So V1, V2, V3 are what? They are nothing but resultant volume after mixing. So these are the relationship between molarity and normality. Okay. So we'll solve a question based on this. So we have seen different formulas. So now we'll see some questions. So 25 ml of solution of barium hydroxide on titration with 0.1 molar solution of hydrochloric acid gave a titer value of 35 ml. The molarity of barium hydroxide solution was. Yes. How do you find this? Yes, try solving it. So 25 ml of solution of barium hydroxide on titration. So this is molarity. This is a problem on molarity. Okay, this is a problem on molarity. Yes. So what is the reaction? Just see. Okay, so it is what? Barium hydroxide, right? Barium hydroxide is reacted with what? It is reacted with a hydrochloric acid. So hydrochloric acid is what? HCl. So this gives you what? It gives you barium chloride plus H2O. So this is the reaction. Okay, barium hydroxide is titrated with hydrochloric acid. Now barium hydroxide. So barium hydroxide you keep one side and one side you keep HCl. So what is the formula you're going to use? M1 V1 is equals to M2 V2, right? So you know acidity and basicity, right? So acidity of base is what? Is 2. So this you divide by 2, and HCl, the basicity of HCl is 1. So this you divided by 1. So M1. Okay, we have to find the molarity of barium hydroxide. So we don't know what is M1 is this, okay, into V1. What is the V1 of barium hydroxide? It is 25 ml, right? It is 25 ml divided by 1 equals to M2. What is molar concentration of HCl? It is 0.1. V2 is what? It is 35. Okay, and divided by 2. Yes. So take M1 one side and this, okay, you take the value and you divide this. So what you get M1? Yes. So solve for 0.1 into 35 divided by 2 first. Okay, whatever the value you get, then transfer this 25 that side. Okay, you will divide it. So it will be C, right? The answer after solving, you will get 0.07 molar. Okay, so the answer is C. The answer is C. I hope you have understood. So this is a molarity problem. So molarity is what? M1 V1, M2 V2. So you are going to use this particular formula. So we'll go for the next one. Yes. So 6.022 into 10 raised to 20 molecules of urea are present in 100 ml of its solution. The concentration of solution is, yes. So there are these many molecules of urea is present in 100 ml of its solution. So they have asked what is the concentration of the solution. Yes. So 1 mole, how do you write this? So 1 mole of urea. Okay, 1 mole of urea means what? Avogadro's number. It consists of Avogadro's number. So it is 6.022 into 10 raised to 23 molecules, right? In 1 mole of urea. So we have taken a general statement that in 1 mole of urea, there are Avogadro number of molecules. That is 6.022 into 10 raised to 23. Okay. Then number of moles. So we have to calculate number of moles of urea in 6.022 into 10 raised to 20. Okay. So how will calculate? You have to cross multiply, right? So for 1 mole of urea, these many are there. So for number of moles of urea in these many molecules are how much? So it will be what? 6.022 into 10 raised to 20 divided by 6.022 into 10 raised to 23. So this comes to 0.001 mole. Okay. Now, how do you find the concentration? They have asked what? They have asked the concentration of solution. So concentration of solution is nothing but number of moles of solute. Okay. Number of moles of solute divided by, okay, divided by volume of solution in liter. Volume of solution in liter. This is what? This is ml, right? It is ml, means what? This is in molarity problem, right? It is a molarity. So number of moles of solute divided by number of solution in liters. Okay. So what you get? So this is 10 raised to 3, right? 10 raised to 3 divided by 100 into 10 raised to 3. It is milliliter, right? So it is 10 raised to 3. So this comes to what? It comes to 10 raised to, yes, 2. Okay, that is 10 raised to 2. So B. Yes, B is the answer. Okay, so the B is the answer. So like this, you are going to solve the problem. I hope you have understood. So first, you have to see number of moles. Okay, how many number of moles are present? So then you have to find the concentration. So how many moles of solute is present, and then find the concentration. So this is the way you are going to solve it. Next, a 5.2 molar aqueous solution of methyl alcohol, that is CH3OH, is supplied. What is the mole fraction of methyl alcohol in the solution? So this is a mole fraction problem. Okay, so this is a mole fraction problem. How do you solve this mole fraction problem? Yes. What is the answer? How will you solve this? Yes. It is what? So how many number of moles are there? So number of moles of CH3OH. Okay, CH3OH is how much? It is N2 is equals to 5.2. Right. So number of moles of CH3OH, that is N2, is given as 5.2. Then so it is molar aqueous solution. Okay, so what we have to find? Now we have to find for what is the mole fraction of methyl alcohol in the solution. So so your alcohol is dissolved in the water, aqueous solution in water. So number of moles of water. Okay, water is what? It is N1. It is given as N1. So how will find it? It is 1000 divided by 18. Okay, so so this is the equivalent weight by its molecular weight. So you get 55.5. You get 55.5. Now apply the mole fraction problem. Okay, mole fraction of CH3OH. So what is the formula? It is N2 divided by N2 plus N1. Okay, N2 divided by N2 plus N1. So what is N2? It is 5.2. N2 is 5.2 plus N1 is 55.5. Yes. Solve this and tell me the answer. Yes. It comes to, what will be the answer? So you know, for mole, if they have asked the mole fraction, you have to know what is N2, what is N1, right? So number of moles of CH3OH is given. The another, this is N1 is what? It is a aqueous solution. That is your methanol is dissolved in water, right? Alcohol, aqueous solution. So it consists of water. So N1 is this, okay? Yes, it comes to, the answer is C. Yes, the answer is C. That is 0.086. Okay. So the answer is C. So this is a mole fraction problem. The molality. So this is a molarity problem. So molarity of a solution obtained by mixing 750 ml of 0.5 molar solution of HCl with 250 ml of 2 molar solution of HCl will be. Yes. So this is what, this is a mixing problem. Okay, mixture. Okay, it is a mixing problem. So how will you solve this? We had seen this particular formula. So molarity of solution obtained by mixing to 750 ml of 0.5 m solution of HCl with 250 ml of 2 m solution of HCl. Okay, so there are two concentrations of HCl. Okay, so we have to find the molarity of one. So there are two HCl solutions. One concentration is known. So that mixing of 0.5 solution of HCl with another of 2m. So there are two solutions. So we have to find the molarity of solution obtained after mixing this two. So how will you take this? It is M3V3 equals to M1V1 plus M2V2. Right. So M3. M3, we have to find the M3. So you know volume which is obtained. So if you add this two, you will get what is V3, right? So it will be what? M1 V1 plus M2 V2 divided by V1 plus V2. Okay, V1 plus V2 will give you a V3, right? So like this, you are going to substitute. So what is M1? M1 is 0.5. What is V1? V1 is 750. Okay, plus what is M2? It is 2. What is this? It is 250. What is V1, V2? It is 750 plus 250. So solve this. Yes, Damini. Yes, the answer is what? The answer is 0.875. Okay, so the answer comes to be 0.875. So this is the answer. So solve this and you will get the answer. I hope you are understanding the problems. Yes. So we'll go for the next one. So when the concentration is expressed as the number of moles of solute per kg. So when the concentration is expressed as number of moles of solute per kg of solvent, then it is called as what? What it is called as? Number of moles of solute per kg. Yes. What is the answer? What it is called? Molarity, normality, molality, mole fraction. See, number of moles of solute per kg, not per liter. If it is per liter, then it is molarity. Per kg means, yes, it is molality. Okay, remember this, the difference between molarity and molality. This is number of moles of solute per kg. Okay, number of moles of solute per kg. Molarity is what? Number of moles of solute per liter. Okay, it is per liter. Remember this. Remember this. Very important. Okay. So we'll go for the next one. So next is Henry's law. Okay. So what is Henry's law? The partial pressure of the gas in a vapor phase is proportional to the mole fraction of a gas in the solution. So the partial pressure of the gas in vapor phase is proportional to the mole fraction of a gas in the solution. So pressure, okay, the partial pressure is expressed as P, which is directly proportional to the mole fraction, that is psi here. Or if you remove the proportionality constant, okay, they have introduced the constant KH called as Henry's law constant. Okay, this side indicates what? This indicates your mole fraction of the gas in the solution. So higher the value of KH at a given pressure, lower will be the solubility of the gas in the liquid and vice versa. So this is Henry's law. Henry's law states what? That is the partial pressure of a gas in the vapor phase is proportional to the mole fraction of a gas in the solution. So this is Henry's law. So next is Raoult's law. Okay, what does Raoul states? What is his law states? That it states that for a solution of volatile liquid, okay, for a solution of volatile liquid, the partial vapor pressure of each component, okay, so for a partial vapor pressure of each component in the solution is directly proportional to its mole fraction. So this is Raoult's law. What is Raoult's law? It states that for a solution of volatile liquids, okay, volatile liquids, the partial vapor pressure of each component, okay, each component, what happens? The solution is directly proportional to its mole fraction. So this is the Raoult's law. Okay, this is what? This is Raoult's law. So according to Raoult's law, for component one, okay, each component is directly proportional to the mole fraction. So how it is given? So P1, okay, so partial vapor pressure of first component P1 is equals to P1 naught into psi 1. For component 2, P2 is equals to P naught okay, P2 naught into psi 2. Okay, so this is according to Raoult's law. So where P1, so this P1 and P2 are called as what? They are called as a vapor pressure, partial vapor pressures of two components respectively. And P1 naught and P2 naught are the vapor pressures in pure state. So these are the vapor pressures in pure state. And psi 1 and psi 2 are the mole fractions of the two components. So if you want to calculate the total vapor pressure, so we have calculated for each component. Okay, so if you want to calculate for the total vapor pressure, then how it will be? P total. You have to take P total, that is sum of the partial pressures. So it is P1 plus P2. So like this, you are going to calculate the total vapor pressure. Next is ideal solutions and non-ideal solutions. So you have seen this. It is a very important. You have studied this in your theory part. So in your CET also, this is very important. Ideal solutions and non-ideal solution. What do you mean by ideal solution? So ideal solution is one in which it obeys Raoult's law. Okay, and what is non-ideal solution? Non-ideal solution is one which does not obey Raoult's law. So it obeys Raoult's law means what? So this is the mathematical expression. Okay, for that each component of the partial pressure is directly proportional to its mole fraction. Okay, so here it does not depend on Raoult's law. So you can see the mathematical representation. Then delta H. Okay, delta H is what? It is the enthalpy of mixing. So the enthalpy of mixing of the pure component to form the solution is 0. Okay, and the volume of mixing is also 0. So that is delta H mixing is nothing but a enthalpy of mixing of the pure component. So this is 0. And for non-ideal solution, the enthalpy of mixing of components to form the solution is not equal to 0, and the volume of mixing is also not equal to 0. So this is under non-ideal solution. So AB interactions, AB interaction is equal to AA and BB interactions. Here AB interactions are not equal to AA and BB interactions. So these do not form azeotropes. So ideal solution, they do not form azeotropes. Non-ideal solution, they form azeotropes. So some questions. Out of the below two compounds, the vapor pressure of B at a particular temperature is? Yes. So out of the below two, so there are two compounds which are given. So there are two compounds which are given. The vapor pressure of B at a particular temperature is? Yes, it is higher than A. Okay, it is higher than A. Why? What is the reason? So in B, you can see the molecule. It involves what? It involves the what type of bonding is present here? Yes, can anyone tell me what type of bonding is present here? Yes. Yes, what type of bonding is present? Yes, intramolecular hydrogen bonding. Yes, Damini, good. Okay, so there is intramolecular hydrogen bonding is present. Okay, intramolecular hydrogen bonding is present. So because of this, what is happening? So in A, there is intermolecular hydrogen bonding. So in this, it is intermolecular hydrogen bonding. So vapor pressure of, because of this reason, because it is within the molecule, there is hydrogen bonding. So the vapor pressure of B is more higher than that of A. Yes, good. In a mixture of A and B, components show negative deviation. When they will show negative deviation, A and B components, in a mixture of A and B, components show negative deviations. When they show negative deviation, yes, when they will show negative deviation, they will show the negative deviation. The answer is A. Okay. AB interaction is stronger than AA and BB interaction. So if the AB interaction is stronger than AA and BB interaction, then it will show a negative deviation. Okay.
Negative deviation. Okay. And be interaction stronger there too.
Which of the following liquid pairs will show positive deviation from Raoult's law? Which of the following liquid pairs will show positive deviation from Raoult's law? Yes, Damini, yes, it is D. Okay, benzene methanol. It shows positive deviation. So this it shows positive deviation. Okay. So next we'll see colligative properties. So there are 4 colligative properties, that is relative lowering of vapor pressure, elevation of in boiling point, depression in freezing point, and osmotic pressure. So what is relative lowering of vapor pressure? So here it is P naught A minus PA divided by P naught A equals to XB is equals to NB by NA plus NB. Okay, so this is relative lower pressure. Okay, lowering of vapor pressure. So where NB is your number of moles of solute. Okay, Na is number of moles of solute in A. So that is equals to NB equals to, so it becomes NB equals to Na when a dilute solution, for a dilute solution where NB is very less than Na. So the relative vapor pressure, lowering of vapor pressure is given as WB into MA divided by MB into WA, where WB is mass of solute, WA is mass of solvent, MB is molar mass of solute, and MA is the molar mass of solvent. So whenever you have a questions on relative lowering of vapor pressure, you're going to use this particular formula. This particular formula is used. Okay. Next. Elevation in boiling point. So elevation is boiling point is given as delta TB. Okay, is equals to KB in bracket WB into 1000 divided by MB into WA. So this can be given as MB. Okay, MB is equals to 1000 into WB into KB divided by delta TB into WA. So where KB is the molar elevation constant having unit Kelvin kilograms per mole. So this is the formula for calculating your elevation in boiling point. Okay, elevation in boiling point. Next, depression in freezing point is given as delta TF is equals to KF into WB into 1000 divided by MB into WA. Or it can be written as MB is equals to KF into WB into 1000 divided by delta TF into WA, where KF is your molar depression constant having unit Kelvin, kg, per mole. Okay, so this is the depression in freezing point. Next is osmotic pressure. So osmotic pressure of a solution is the excess pressure that must be applied to a solution to prevent osmosis. Okay, so this is osmotic pressure. It is given as pi is equals to CRT is equals to NV divided by V into RT. Where if you rearrange it, it can be written as pi V is equals to WB RT divided by MV, or MB is equals to WB RT divided by pi V, where pi is called as osmotic pressure and R is your gas constant. So this is the formula for calculating your osmotic pressure. So we'll see some questions now. So this is a question on elevation in boiling point. So aqueous solution freezes at minus 0.186 degrees Celsius. What is its elevation in boiling point if Kf is equals to 1.86 and Kb is equals to 0.512? Yes. What is the formula? So delta Tf is equals to Kf into M. Okay. So here delta TF is what? 0.186 into KF is what? 1.86. Okay. So what is M? So first we'll see what is M. So M is equals to 0.186 divided by 1.86. So this comes to 0.1 M. So now delta TB, we are finding what is the elevation in boiling point. It is delta TB. So delta TB is equals to KB into M. Okay. So KB is what? What is the value for KB? It is 0. Into what is M is 0.1. Yes, solve this. What will get the answer? What is the answer? It is 0.0512. Yes. So the answer is D. So this is the way you're going to find the elevation in boiling point. During depression in freezing point in a solution, the following are in equilibrium. What is in equilibrium during depression in freezing point? Depression in freezing point. What are in equilibrium? Yes, Abhishek. The answer is A. It is a liquid. Okay, it is what? A liquid solvent and solid solvent. Okay, they are in equilibrium. Why? What is the reason? So at freezing point, the liquid and the solid are in equilibrium. When a solution of a non-volatile solvent solute is cooled to temperature below the freezing point of solution, some of the liquid solvent will separate out as a solid solvent. Okay, so what happens? So whenever at freezing point liquid and solid are in there, so a solution of non-volatile solute is cooled. So the non-volatile solution is cooled so to a temperature which is less than that of freezing point of the solution. And what happens? Some of the liquid solvent, it will separate out as solid solvent. So whenever a depression in the freezing point, the liquid solvent and solid solvent will be in equilibrium. Next, which one of the following statement is false? Which one of the following statement is false? The correct order of osmotic pressure of 0.01 molar aqueous solution of each compound is BaCl2 is greater than KCl is greater than CH3, COH, acetic acid is greater than sucrose. The osmotic pressure pi of a solution in a given by the equation pi MRT, where M is the molarity of the solution. Raoult's law states that the vapor pressure of component over a solution is proportional to its mole fraction. two sucrose solutions of same molarity prepared in different solvent will have the same freezing point depression. Which one is a wrong statement? Yes, D. Damini, yes, it is a D. Okay. D is a false statement because different solvents have different values of Kf. So it is said what two solutions, sucrose solution will have a same freezing point. No. So different solvents of different values will have different values of Kf. Thus, what will happen? Thus, Tf uh, will be different even if the molality is same. Even if the molality is same, the Tf factor delta Tf will be different. Okay. So all the other three statements are right. The fourth one is a false statement. Which of the following aqueous solution will exhibit highest boiling point? Yes. Not D. D is not the answer. Yes. Lohit, it is C. Okay. Why it is C? Can anyone tell me why it is C? Yes, why it is C? Why it exhibits highest boiling point? What you can see in the different compounds, aqueous solutions? Why it is C? The answer is C. Yes, but why it is C? Why it exhibits highest boiling point? See in Na2SO4. Okay, in Na2SO4, how much ions it will give? It will give you 2 Na plus and 1 SO4 minus 2, right? So what happens? Therefore, 0.01 molar of Na2SO4 will give how much? It will give you 0.03 moles of particles. Okay. And other solute, they will give lesser number of particles. So because of this reason, your C, that is 0.01 molar Na2SO4. So others, urea, KNO3, you can see. This is +1, this is -1. So both are having, they are having 2 particles are there. Here there are 3, right? So because of this reason, number of particles will be given more by the Na2SO4. Okay. So we'll go for the next one. Van 't Hoff factors. Okay, what is Van 't Hoff factor? So to calculate extent of association or dissociation, Van 't Hoff factor introduce a factor that is I, known as the Van 't Hoff factor. So I is equals to total number of particles after association divided by number of particles before association. I is also given as observed colligative property divided by calculated colligative property. So I is equals to normal molar mass divided by abnormal molar mass. So these are the I is nothing but your Van 't Hoff factor. Okay, so these are the different definitions. For dissociation, when you get dissociation, when I is greater than 1, and for association, I is less than 1. So relation between Van 't Hoff factor and degree of dissociation is given as I is equals to 1 minus alpha plus n alpha, where n is the number of particles after dissociation. Relation between Van 't Hoff factor and degree of association is given as I is equals to 1 minus alpha plus alpha divided by n, where n is the number of particles undergoing association. So these are the Van 't Hoff factor. Okay. So if alpha is the degree of dissociation of Na2SO4, the Van 't Hoff factor I used for calculating the molecular mass is. Yes, we have seen the definition just now. We have seen how to calculate what is the different this. How do you calculate the degree of dissociation is given. Okay, for alpha is the degree of dissociation for Na2SO4, the Van 't Hoff factor I used for calculating the molecular mass is. Yes. What is the answer? Not B. B is not the answer. See, Na2SO4 gives you what? It gives you 2Na plus SO4 minus 2. Okay. So it is 1 mole. One. So this will be 0 here. This also will be 0. So this is 1 minus alpha. This is 2 alpha. This is alpha only. So the I factor is given as 1 minus alpha plus 2 alpha plus alpha divided by 1. Okay. So it is 1 plus 2 alpha. The answer is C. The answer is C. Okay. 1 plus 2 alpha. So we'll solve some questions from previous year's paper. Yes. So osmotic pressure of the solution can be increased by, okay, A, increasing the temperature of solution, B, decreasing the temperature of solution, C, increasing the volume of vessel, D, diluting the solution. Yes. How do you increase the osmotic pressure? How will you increase the osmotic pressure? How it can be increased? Yes. See here, you know that the osmotic pressure of a solution is affected by what? It is affected by its concentration of solute and temperature, right? So osmotic pressure is affected by its concentration and temperature. So you know what is C? C is what? C is mole per liter. T is Kelvin. So if mole, okay, if your osmotic pressure is directly proportional to what? It is directly proportional to concentration as well as it is directly proportional to temperature. So if you increase the temperature, what will happen? Your osmotic pressure also will be increased. So you have to increase the temperature of the solution. So the answer is what? The answer is A. So increasing the, yes. So the answer is what? The answer is A. Okay. Answer is A. So this is the first question. So we'll go for the next one. When an electrolyte, when an electrolyte is dissociated in solution, the Van Hoff factor is A greater than 1, B less than 1, C 0, D equals to 1. Yes, when electrolyte is dissociated in solution, what is Van Hoff factor? It is what? Less than, greater than, or 0 or 1. It is, we have seen this here. Yes. What is the answer for association? Dissociation, 1 is greater than 1. For association, it is less than 1. So this is what? 1 is greater than 1. Okay, it is 1 is greater than 1. So the answer is what? A. Yes, the answer is A. For dissociation, it is greater than 1. So answer is A. Right? So next one. Which of the following is not a colligative property? Is not a colligative property. A. Osmotic pressure. B. Optical activity. C. Depression. D. Elevation in boiling point. Yes. Yes. Good. The answer is B. Optical activity. Optical activity does not relate it with colligative property. Okay. So, colligative property depends upon the osmotic pressure, your depression, your elevation in boiling point. Optical activity means what? It is the ability of a chiral molecule to rotate the plane polarized light. So it does not come under the colligative property. So the answer is what? Answer is B. Okay, good. So we'll go for the next one. When the pure solvent diffuses out of the solution through the semi-permeable membrane, then the process is called. Yes, any guesses? Osmosis. B. Reverse osmosis. C. Sorption. D. Dialysis. Yes. What is the answer? Yes, what is the answer? Yes. The answer is what? Answer is reverse osmosis. Right. Okay. The answer is reverse osmosis. So what is reverse osmosis? In which the pure solvent diffuses out of the solution to the semi-permeable membrane. Okay. So it is B. The answer is B. Next. Van 't Hoff factor. Van 't Hoff factor I accounts for. What it accounts for? It accounts for what? Extent of solubility of solute. B. Extent of dissociation of solute. C. Extent of dissolution of solute. D. Extent of mobility of solute. Yes, what is the answer? What does Van 't Hoff this Van 't Hoff factor I account for? What it tells you about Van 't Hoff factor? How it is dissolution of solute? It is what? I. It accounts for what? Yes, it accounts for dissolution, dissociation, right? It accounts for dissociation of solute. The answer is B. Okay, the answer is B. One more. Which of the following aqueous solutions has highest freezing point? We have seen this question, one question like this. 0.1 molar Al2SO4 thrice. We have seen this for boiling point, right? This is for freezing point. BaCl2, C 0.1 molar AlCl3, and D 0.1 molar NH4Cl. Yes, what is the answer? What is the answer? This is for freezing point. Okay, highest. Which of the following aqueous solutions has highest freezing point? All are saying B. Are you sure? Is it B? A. We have asked for highest freezing point. Okay. So when the answer is D. Okay, the answer is D. Why it is D? Because NH4Cl, it will dissociate into what? NH4 plus plus Cl minus. So lesser the number of particles available, higher will be the freezing point. Okay. So your I is what? I is 2. Okay, in this case it is it depends upon the freezing point. We have discussed about boiling point. This is about freezing point. So lesser the number of particles available, higher will be the freezing point. So your I is equals to 2. So which is least among all. So it has the highest freezing point. So it has the highest freezing point. Okay, understood. So for freezing point, so lesser the number of particles, more will be the highest will be the freezing point. Okay. So next, now you tell me this one. Which of the following aqueous solutions should have the highest boiling point? A 0.1 molar NaOH, B 1 molar Na2SO4, C 1 molar NH4NO3, C 1 molar KNO3. Yes. Now, highest boiling point. Highest boiling point. Yes. Answer. Which of the following will be highest? See here, NH4 will be in +1 state. This is +1, this is -1, this is +1, -1. These are 2, Na2. So Na plus are how many? 2. Na plus are there and 1 SO4 minus is there, 2. Right? So there are 3 particles. So highest. So listen here, what is the statement for your boiling point? Is that, see, colligative properties of the solution, they depend upon the concentration of solute molecules, okay, or the ions which are present, okay, and not the identity of the solute. So here concentration of all the solution are given 1, right? So here all the concentration is what? It is 1 only. Colligative property now, it depends on what? It depends upon the number of ions or the molecules which are present. So the boiling point increases as the number of ions will increase, right? So the number of ions in NaOH are how many? There are 2, because Na is plus, OH is minus 1. So that is one ion of Na plus, 1 ion of OH minus. Then in Na2SO4 is how many? There are number of ions will be 3, because 2 Na plus are there and 1 SO4 minus 2 is there. And in C option, there is 1 NH4 plus and 1 NO3 minus. So there are 2 ions again. And in D, 1 K plus and 1 NO3 minus. So there are how many? Again 2 ions. So in case of C, there are 3 ions. So it depends, the concentration or colligative property depends upon the concentration of or number of ions present. So the ions number of so more the number of ions, higher will be the boiling point. So it is B. Okay, the answer is B. I hope you are understanding the questions. Okay. One more question. Solution A. Okay, solution A, just I'll read out it. Solution A contains acetone dissolved in chloroform, and solution B contains acetone dissolved in carbon disulfide. The type of deviation shown, deviations from Raoult's law shown by solution A and B are. Okay, so one solution is what? One solution is made up of acetone plus your chloroform. Okay, chloroform. So this is A, and B is what? Acetone dissolved in your carbon disulfide. Okay, so what type of deviation is shown? A is what? Positive and positive. B is positive and negative. C is negative and negative. D is negative and positive. Yes, tell me the answer. Here, acetone and carbon disulfide, it will show positive deviation. Okay, it will show positive deviation. So this will show positive deviation according to Raoult's law. And okay, what is Raoult's law? That is the vapor pressure of each component is directly proportional to its mole fraction. So total vapor pressure predicted will be greater by its Raoult's law. So acetone and chloroform, it will show you what? Negative deviation. Okay. So acetone plus chloroform showing negative, and this is positive. So the answer is what? Answer is D. Okay, the answer is D. Yes. So by this we have completed the chapter solutions. I hope you have understood the questions. Okay. So we'll meet in the next class with another chapter. Okay. Thank you. We'll stop it for today. Yes. Thank you. Bye. Good. Have a good day.